Hey guys, so this is our Monday lesson. So hopefully you watched the video that I posted on Friday. You didn't have to actually do anything. I gave an extra credit assignment to go with it, but it was really just preparing you. And this is another lesson. I actually am going to give you homework on this though, because we're going to need these skills for our next unit, which we're going to start on Wednesday. So we are going to talk about rationalizing the denominator of a fraction. All right, so this talks, when you're rationalizing, we need to know our perfect squares. So let's write down what are our perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. So the ones in the boxes are the perfect squares, right? The square root of 36 is 6. The square root of 49 is 7. So these are all, there are more perfect squares than these, but these are like the small ones that we use the most. So really ugly 225. Okay, so this is a review of Friday, that video I made for you guys to watch. So pause the video and try number 1 on your own. So we always start off by writing down everything that multiplies to 40. So 1 times 40, 2 times 20. 3 doesn't go into 40, so I'm going to skip 3. 4 times 10, and 5 times 8. Then I'm going to go through and I'm going to find all my perfect squares. 1 is a perfect square. We don't know the square root of 40. We don't know the square root of 2. 20, we don't know. 4, the square root of 4 is 2. We know that one. 10, nope. 5 and 8. So we're going to go with which perfect square is the biggest. The 4 is the biggest. So we're going to rewrite 40. 40 equals 4 times 10. And then a property of square roots, we're allowed to break it up. Square root of 4, the square root of 10. What's the square root of 4? 2. What's the square root of 10? I have no idea, so I rewrite it. 10. And we just simplified our square root. Number 2. Again, pause the video. Try it on your own. 98. 1 times 98. 2 times 49. 3 doesn't work. 4 doesn't work. The only other number that works is 7 and 14. And you can use your calculator. Grab your calculator. 98 divided by 3. 98 divided by 4. 98 divided by 5. So then we look for our perfect squares. 49 and 1. And pretty much if it's 1, you're going to ignore it. So 2 and 49. So 98. Sorry, I'm dropping my iPad. Is 2 times 49. Okay, come on. There we go. So then again, I can break this up. Square root of 2. Square root of 49. Do I know the square root of 2? No. And always ask yourself that. Kids always mess up what goes in, what goes out. Ask yourself, do you know the square root of 2? I have no idea. Do I know the square root of 49? Yes, 7. And then I like to put the number in the outside. Don't leave it like that. Don't leave it like this. It's weird looking. Okay, 2 more of these. So pause your video. Try to simplify the square root of 75. 1 times 75. 2 doesn't work. 3 times 25. 4 doesn't work. 5 times 15. And that's all the numbers. So look in that list. Where is your perfect square? 25. Now don't drop that 2. So it's 2. 3 times 25. 2 root 3 root 25. Can't do anything with that 2. I don't know the square root of 3. The square root of 25 is 5. Now we're going to take the two things that are not under the square root. These are really multiplying, right? Just like with 2x, 2x means 2 times x. So 2 root 3 means 2 times root 3. So this is all multiplication. So we're going to multiply the 2 and the 5, and that's your answer. All right, last one like this, 162. 1 times 162, 2 times 81, 3 times 54, 4 doesn't work, 5 doesn't work, does 6 work? No, I don't think so. Well, it's 81 anyways. If you can see that you're a big perfect square, you can just stop. 5 root 2 times 81. 5 root 2, root 81. Can't do anything with a 5. Don't know the square root of 2. The square root of 81 is 9. Again, multiply those together. 45 root 2. And this is also a good prep for Algebra 2 next year. You do a lot of this in Algebra 2. Okay, so now we're going to get into the geometry stuff that we need. What is a rational number? So a rational number is a number that can be written as a fraction. So square roots that are not decimals are not rational. So they are called irrational, okay? So like the square root of 7 is an irrational number. There's no way to write that without that square root. Pi is the most famous irrational number. Okay, so pretty much when it says irrational, there we go. When it says rational versus irrational, rationalize the denominator, we're getting rid of our square roots. So that's actually what we're doing here. So to rationalize the denominator of a fraction, we are, can I just slide that away? Yeah, I can. Write the fraction so there are no square roots in the denominator. So we're getting rid of the square root, right? So if that helps you, get rid of the square root in the bottom of the fraction. It's a really common practice when you get into higher level math to do this. Okay, so to rationalize the denominator, here's the process. I don't want that square root of 2 to go away. So what we're going to do is we're going to multiply it by itself. Because what is the square root of 2 times the square root of 2? Well, that's the square root of 4. Do we know the square root of 4? We do. The square root of 4 is 2. So we're going to multiply it by itself. But it's a fraction, right? You can't just magically multiply. So whatever you do to the bottom, we have to do to the top. So 1 times the square root of 2 is the square root of 2. So the answer is the square root of 2 over 2. Now this probably doesn't look any better to you, but as a math teacher it looks better to me because we no longer have a square root in the bottom. The bottom is just a regular 2, no square root. And that's the goal, to rewrite it so there's nothing in the bottom. No square root in the bottom. All right, so number 6, same idea. Whatever square root you see in the bottom, that's what we're going to multiply by. So I see the square root of 3, so I'm going to multiply by the square root of 3. Whatever you do on the top, you do on the bottom. So we get 5, the square root of 3, over the square root of 3 times the square root of 3 is the square root of 9. But I know the square root of 9. The square root of 9 is 3. Now, you cannot divide those. Because this one's in the square root, you can't divide those out. That's not allowed. Okay? You are not allowed to put those together. Those are two different numbers, even though they look similar. We are done with that problem. That is your answer. All right, so 5 root 3 over 3 is an answer. All right, I want you to pause the video and try 7 and 8 on your own. All right, so number 7, square root of 7, whatever we do on the bottom, we do on the top. 14 root 7 over the square root of 49. So we get 14 root 7 over 7. Now this one we can simplify, but we're not simplifying this. We're simplifying this. 7 goes into 14 how many times? So this simplifies to 2. 2 root 7. And that's your answer. So the root 7 stays. It's the 14 divided by 7. That's 2. All right. Next one. All right, so root 8, 3 root 8 over square root of 64. 3 root 8 over 8. But there's actually more to do here. Whoops. So look at this really closely. What did we do earlier in the lesson? We simplified. So if you look at like the square root of 3, is there a perfect square that goes into the square root of 3 up here? No, it's just a 1, right? 1 times 3. 2 is 1 times 2. 7 is 1 times 7. There's no perfect square other than 1. But what perfect square goes into 8? 8 is 4 times 2. I can simplify that. So I'm going to make this 3 root 4 root 2. 3 times 2 root 2. 6 root 2. And then don't forget my 8. I'm going to bring that 8 over. And then I can simplify that fraction by dividing by 2. 3 root 2 over 4. And that's your answer, right? So that one's pretty much, that's as hard as we would get in this class. All right, I think these are the last two. So same idea. This one's a little different with the multiplying though. So just like before, I'm going to multiply the top and the bottom by root 2. Now, since those are both under a square root, the 5 and the 2, right? This one's under a square root, this one's under a square root. We're allowed to multiply those together. So that gives us root 10 over root 4. Do I know the square root of 4? I do, it's 2. And then square root of 10. Now, can you simplify the square root of 10? 1 times 10. 2 times 5, you can't, because the only perfect square is the 1, so you can't do anything there. This is your answer. All right, and then number 10, root 5, Everything's under a square root, so I'm allowed to multiply. That's the square root of 60 over the square root of 25, which is the square root of 60 over 5. Now we need to check. Can I simplify 60? Let's go over. Oops. Why are you doing this? 60. Oh, stop moving. There we go. All right. 1 times 60. 2 times 30. 3 times 20. 4 times 15. 5 times 12. 6 times 10. So look for the perfect square. 4 and 15. Yes, again 1, but that's silliness. So I'm going to rewrite 60 as 4 times 15. So it's the square root of 4 times 15. The square root of 4, square root of 15. That was a really ugly one. So I get 2 root 15 and then over 5. Don't forget that 5 that was on the bottom. And we are done. I lied. Okay, last thing. Sorry, guys. I'm a liar. My bad. So what is the square root of 5 quantity squared? So that means a square is times itself. So That's the square root of 5 times the square root of 5. That's the square root of 25, which is just 5. So that's a lot of work. You should just recognize that a square root and a square, they kind of undo each other. So the square root of 5 squared is just 5. So what would be the square root of 11 squared? 11. Now number 13 is a little harder. So this is 2 root 7 times 2 root 7. So the root 7s cancel out, right? So that's square root of 49, which is 7. But you also are going to multiply the 2's together. What's 2 times 2? 4. So this one you end up getting 28. So basically you have to square the 2. So 2 squared is 4 times your 7 is 28. So pause the video and try the last one, 14, on your own. So this is 3 root 10 times 3 root 10. My root 10's multiplied give me root 100. My 3's multiplied give me 9. Now 9 is not under the square root. And a lot of kids, they'll try to take the square root of 9. Nope, no square root there. So 9 times the square root of 100 is 10. So our final answer is 90. All right, so again, the purpose of the lesson, our next unit is on triangles, and we're going to be using these skills. So that's the purpose of the video from Friday and today. I really just want you to be prepared for our next entire unit, actually. The next 2 weeks worth of lessons, we're going to be using this. All right, so do the homework. It's due on Wednesday by class time. Email me if you have any questions, and have a fabulous day, guys.